Welcome to this explainer. Look, today we're tackling one of the most absolutely critical yet notoriously complex challenges in modern network security, and that is firewall decryption. If you've ever felt like setting up decryption is basically a delicate tightrope walk between getting complete network visibility and completely crashing your network's performance, well, you're definitely in the right place. We're going to demystify this whole process. We'll use the logic of Palo Alto Networks firewalls as our guide, and we're going to turn what honestly feels like a technical minefield into a clear, strategic advantage for you. Here is our visual roadmap for today. We're going to cover types of decryption policies, the exception strategy, technical challenges, intelligent URL filtering, and finally, the correct rule order. Section 1. Types of decryption policies. Okay, let's dive into this and look at the fundamental tools the firewall actually gives us. So the firewall essentially offers us three main types of decryption policies, and they each serve a very distinct purpose based on which way the traffic is flowing. First up, we've got the SSL forward proxy. This is your primary tool for controlling outbound traffic. Think of it as keeping a close eye on your internal users as they browse the wild west of the internet. Second, we have SSL inbound inspection. This flips the script entirely. It controls inbound traffic to protect your internal servers and apps from external threats that love to hide in encrypted connections. And third, there's SSH proxy, which is specifically designed to inspect SSH connections because, let's face it, malicious actors absolutely love using those to hide their command and control tunnels. Now, it's highly important to understand the core technical difference between how these operate. For SSL decryption to actually work, the firewall has to act as a man in the middle. It requires certificates to present itself as a trusted entity to both the client and the server. Without that mutual trust established, the whole connection just breaks. SSH proxy, on the other hand, operates completely differently at the protocol level. It intercepts the tunnel, sure, but it doesn't require you to manage and deploy certificates in that same way. To give you even more control over these policies, you apply what's called a decryption profile. Think of the policy rule as the thing deciding what traffic to intercept, and the decryption profile as deciding how to handle the incredibly messy reality of the internet. The profile gives you precise, super granular control over things like what exactly happens when you encounter an expired certificate, an untrusted issuer, or a random handshake error. It dictates whether you instantly drop that connection to be safe or if you let it slide through. Moving right along to Section 2, the exception strategy, because you can't just apply this stuff randomly. This brings us to the central mantra of our entire strategy today. Seriously, if you take one thing away, it's this: decrypt all and exclude few. This is the absolute gold standard best practice. We operate on the principle that, by default, we want to inspect absolutely everything to ensure maximum security. But, and this is a big but, we deliberately carve out a very small, carefully chosen handful of exceptions. So what makes up the exclude few? Well, these exceptions generally fall into three distinct categories. First, compliance. You really shouldn't be inspecting sensitive financial data or personal medical records. In a lot of regions, doing so literally violates strict privacy regulations. Second, performance. You might have hypercritical business apps that are incredibly latency sensitive, where even a split-second delay from inspection is just totally unacceptable. And finally, technical limitations. And by the way, figuring out these compliance and performance exceptions, that's not just an IT task. You absolutely have to work alongside your legal, compliance, and business teams to get this right. Section 3, technical challenges. Let's look at the roadblocks, because technical exceptions are practically the most common reason decryption breaks. Now, what's really interesting about this slide is certificate pinning. This perfectly explains why some of your most common apps suddenly crash and burn when you turn on decryption. A lot of modern applications, especially mobile apps or thick clients, are hard-coded with a specific certificate just baked right in. They expect to see exactly that certificate from the server. When your firewall steps in and presents its own proxy certificate instead, the app instantly flags it as an attack and drops the connection. There is zero negotiating with a pinned certificate. Another major technical hurdle is mutual TLS, or MTLS. In a normal connection, only the server proves its identity. But with MTLS, it's a two-way street. The client also presents a certificate to authenticate itself to the server. This two-way authentication model is fundamentally incompatible with traditional firewall interception methods. If you try to decrypt MTLS traffic, it's gonna fail for sure. You are pretty much forced to exclude it. But hey, fortunately, we aren't left entirely in the dark to figure this out on our own. Palo Alto actually provides some brilliant built-in solutions to resolve these exact failures. First off, there are default SSL exclusion lists that auto-update via content updates. These contain hundreds of known problematic domains that use certificate pinning or MTLS. Plus, there's a super handy feature for temporary troubleshooting exceptions. This allows the firewall to automatically exclude applications it recognizes are repeatedly failing due to decryption issues, which buys you time to investigate without causing a massive outage. Let's ground this theory in reality with a real-world example. IoT devices. Think of your smart TVs, security cameras, or factory sensors. These devices notoriously rely on certificate pinning. And let's be honest, they're essentially dumb devices. They completely lack the management flexibility for you to go in and install your firewall's trusted root certificate. If you apply decryption to your IoT segments, those devices will just stop working entirely. You almost always have to create specific bypass policies just to keep them on right. All right, Section 4, Intelligent URL Filtering. This is the key to applying decryption intelligently. Categorizing URLs by their actual risk level tells us exactly where we need to focus our inspection efforts. You see, URL filtering isn't just about blocking obvious categories like gambling or social media anymore. We can classify traffic by how risky it actually is. For low-risk, trusted sites, maybe you don't even need to decrypt. But for medium and high-risk categories, we're talking known malicious sites, newly registered domains, online storage where data exfiltration happens, or sites with just terrible SSL practices, you absolutely must prioritize decryption and inspection there. Let's move on and see how this builds. By combining URL categorization with risk levels, you're building a massive overarching efficiency strategy. Your firewall only has so much processing power, right? And decryption is computationally heavy. So this means you can focus the firewall's heavy lifting resources squarely on the most dangerous traffic. You save system CPU while simultaneously boosting your network's overall security posture. It's a win-win. So the crucial point is right here in Section 5. The correct rule order. This is the often neglected art of putting it all together. Whenever we build a rule, we're essentially stacking blocks. We define the source and destination zones. We apply IP or geolocation filters. We specify the decryption type, like forward proxy. And finally, we attach that carefully configured decryption profile. But listen, having all the right building blocks doesn't mean a thing if you build the tower upside down. You absolutely have to respect the top-to-bottom logic of the firewall. Policies are evaluated strictly from the very top of the list to the bottom, and the firewall applies the very first rule that matches the traffic. Then it just stops looking. I literally cannot emphasize this enough. A single rule placed in the wrong order can completely shut down critical business operations or accidentally expose sensitive data. And this brilliantly illustrates the exact, flawless sequence that guarantees maximum coverage without breaking your network. Step 1, right at the very top, your no decrypt exception rules. Compliance, critical apps, and technical bypasses like PIN certificates go right here so they get safely ignored. Step 2, high-risk decrypt. Target those dangerous URL categories immediately. Step 3, additional targeted policies, like specific regional logging or unique segmentation rules. And finally, Step 4, at the very bottom, your decrypt all rule. This acts as the catch-all, ensuring any remaining traffic not explicitly handled above gets fully inspected. This is exactly how you implement decrypt all and exclude few safely. Decryption gives you total visibility, but only if it's implemented with actual intelligence. Mastering the nuance of these policies, really knowing exactly what to exclude and in what exact order, is the ultimate test for modern security professionals. So I'll leave you with this final thought to take back to your own network. How will you balance visibility and performance? Thank you so much for joining this explainer, and seriously, take a good look at your rule order today.